This is that ice cold Michelle fight for that white gold. This one for them hood girls, them good girls, straight masterpieces. Stylin', wildin', living it up in the city. Got Chuck's on with Saint Laurent. Gotta kiss myself, I'm so pretty. I'm too hot. Call the police and the fireman. I'm too hot. Make a dragon wanna retire, man. I'm too hot. Say my name, you know who I am. I'm too hot. And my band bought that money. Break it down. Girls hit you, hallelujah. Girls hit you, hallelujah. Girls hit you, hallelujah. Cause Uptown Funk don't give it to you. Cause Uptown Funk don't give it to you. Cause Uptown Funk don't give it to you. Saturday night and we in the spot. Don't believe me, just watch. Come on. Don't believe me, just watch. 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 Hey, 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 oh! Stop. Wait a minute. Fill my cup, put some nigga in it. Take a sip, sign the check. Julio, get the stretch. Right to Harlem, Hollywood, Jackson, Mississippi. If we show up, we gon' show out. Smoother than a fresh drop skipping. I'm too hot. Call the police and the fireman. I'm too hot. Make a dragon wanna retire, man. I'm too hot. Bitch, say my name, you know who I am. I'm too hot. And my band bought that money. Break it down. Girls hit you, hallelujah. Girls hit you, hallelujah. Girls hit you, hallelujah. Cause Uptown Funk don't give it to you. Cause Uptown Funk don't give it to you. Cause Uptown Funk don't give it to you. Saturday night and we in the spot. Don't believe me, just watch. Come on. Don't believe me, just watch. 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 Hey, 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 oh! Before we leave, let me tell y'all a little something. Uptown, funk you up. Uptown, funk you up. Uptown, funk you up. Uptown, funk you up. I said uptown, funk you up. Uptown, funk you up. Uptown, funk you up. Uptown, funk you up. Come on, dance, jump on it. If you sexed and flown it. If you freaked dead and own it. Don't brag about it, come show me. Come on, dance, jump on it. If you sexed and flown it. Well, it's Saturday night and we in the spot. Don't believe it, just watch. Come on. Don't believe me, just watch. 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 Hey, 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 oh!
In the summer of 2011, as a tourist, I visited the rainforests of Borneo for the very first time. And as you might imagine, it was the overwhelming sounds of the forest that struck me the most. There's this constant cacophony of noise. Some things actually do stick out, For example, this here is a big bird, a hornbill, a rhinoceros hornbill. His buzzing is a cicada. This is a family of gibbons. It's actually singing to each other over a great distance. The place where this was recorded was in fact a gibbon reserve, which is why you can hear so many of them. But in fact, the most important noise that was coming out of the forest that time was one that I didn't notice. And in fact, nobody there had actually noticed it. So as I said, this was a gibbon reserve. They spend most of their time rehabilitating gibbons, but they also have to spend a lot of their time protecting their area from illegal logging that takes place on the side. And so if we take the sound of the forest and we actually turn down the gibbons, and the insects, and the rest, in the background the entire time, in the recording that you heard, was the sound of a chainsaw at great distance. They had 3 full-time guards who were posted around this sanctuary, whose job was in fact to guard against illegal logging. And one day we went walking, as tourists, out into the forest, and within 5 minutes walk, we stumbled upon somebody who was just sawing a tree down, 5 minutes walk, a few hundred meters from the ranger station. They hadn't been able to hear the chainsaws, because as you heard, the forest is very, very loud. It struck me as quite unacceptable, right? That in this modern time, just a few hundred meters away from a ranger station, in a sanctuary, that in fact nobody could hear somebody when a chainsaw gets fired up. I mean, it sounds impossible. But in fact, it was quite true. So how do we stop illegal logging, right? It's really tempting as an engineer always to come up with a high-tech, super crazy high-tech solution. But in fact, you're in the rainforest. It has to be simple. It has to be scalable. And so in fact, what we also noticed while we were there was that everything we needed was already there. We could build a system that would allow us to stop this using what's already there. Who was there? What was already in the forest? Well, we had people. We had this group there that was dedicated, 3 full-time guards that was dedicated to go and stop it. But they just needed to know what was happening out in the forest. The real surprise, this is the big one, is that there was connectivity out in the forest. There was cell phone service way out in the middle of nowhere. We're talking hundreds of kilometers from the nearest road. There's certainly no electricity, but they had very good cell phone service. These people in the towns were on Facebook all the time. They're surfing the web on their phones. And this sort of got me thinking that, in fact, it would be possible to use the sounds of the forest, pick up the sounds of chainsaws programmatically, because people can't hear them, and send an alert. But you have to have a device to go up in the trees, right? So if we can use some device to listen to the sounds of the forest, connect to the cell phone network that's there, and send an alert to the people on the ground, perhaps we could have a solution to this issue for them. But in fact, let's take a moment to talk about saving the rainforest, because it's something that we've definitely all heard about forever. People in my generation have heard about saving the rainforest since we were kids, and it seems that the message has never changed. We got to change, we got to save the rainforest. It's super urgent. This many football fields have been destroyed yesterday, and yet here we are. Today, about half of the rainforest remains, and we have potentially more urgent problems like climate change. But in fact, this is a little-known fact that I didn't realize at the time. Deforestation accounts for more greenhouse gas than all of the world's planes, trains, cars, trucks, and ships combined. It's the second highest contributor to climate change. Also, according to Interpol, as much as 90% of the logging that takes place in the rainforest is illegal logging, right? Like the illegal logging that we saw. So if we can help people in the forest enforce the rules that are there, then in fact we could eat heavily into this 17% and potentially have a major impact in the short term. It might just be the cheapest, fastest way to fight climate change. And so here's the system that you imagine, right? It looks super high-tech. The moment a sound is heard, sound of a chainsaw is heard in the forest, device picks up the sound of the chainsaw, sends an alert through the standard GSM network that's already there to a ranger in the field who can in fact show up in real time and halt the logging. It's no more about going out and finding a tree that's been cut. It's not about seeing a tree from a satellite in an area that's been clear-cut. It's about real-time intervention, right? So I said it was the cheapest and fastest way to do it, but in fact, actually, as you saw, they weren't able to do it, so it may not be so cheap and fast. But if the devices in the trees were actually cell phones, it could be pretty cheap. Cell phones are thrown away by the hundreds of millions every year. Hundreds of millions in the US alone, not counting the rest of the world, which of course we should do. But in fact, cell phones are great. They're full of sensors. They can listen to the sounds of the forest. We do have to protect them. We have to put them in this box that you see here. And we do have to power them. Powering them is one of the greater engineering challenges that we had to deal with, because powering a cell phone under a tree canopy, any sort of solar power under a tree canopy, was an as yet unsolved problem. And that's this unique solar panel design that you see here, which in fact is built also from recycled byproducts of an industrial process. These are strips that are cut down. So this is me putting it all together in my parents' garage, actually. Thanks very much to them for allowing me to do that. As you can see, this is a device up in a tree. What you can see from here, perhaps, is that they are pretty well obscured up in the tree canopy at a distance. That's important because although they are able to hear chainsaw noises up to 1 kilometer in the distance, allowing them to cover about 3 square kilometers, if this one were to take them, it would make the area unprotected. So, does it actually work? Well, to test it, we took it back to Indonesia, not the same place, but another place, to another gibbon reserve that was threatened daily by illegal logging. On the very second day, it picked up illegal chainsaw noises. We were able to get a real-time alert. I got an email on my phone. Actually, we just climbed the tree. Everyone had just gotten back down. All these guys are smoking cigarettes. And then I get an email, and we all quiet down. And in fact, you can hear the chainsaw really, really faint in the background, but no one had noticed it until that moment. And so then we took off to actually stop these loggers. I was pretty nervous. This is the moment where we've actually arrived close to where the loggers are. This is the moment you can see where I'm actually regretting perhaps the entire endeavor. I'm not really sure what's on the other side of this hill. That guy is much braver than I am, Shenny. Okay, but he went, so I had to go walking up. And in fact, we made it over the hill and interrupted the loggers in the act. For them, it was such a surprise. They had never, ever been interrupted before, that it was such an impressive event for them that we've heard from our partners they have not been back since. They were, in fact, great guys. They showed us how the entire operation works. And what they really convinced us on the spot was that if you can show up in real time and stop people, it's enough of a deterrent, they won't come back. So, thank you. Word of this spread, possibly because we told a lot of people. And in fact, then some really amazing stuff started to happen. People from around the world started to send us emails, phone calls. What we saw was that people throughout Asia, people throughout Africa, people throughout South America, they told us that they could use it too. And what's most important, what we'd found that we thought might be exceptional, in the forest there was pretty good cell phone service. That was not exceptional, we were told. And that particularly is on the periphery of the forests that are most under threat. And then something really amazing happened, which was that people started sending us their own old cell phones. So in fact, what we have now is a system where we can use people on the ground, people who are already there, who can both improve and use the existing connectivity, and we're using old cell phones that are being sent to us with people around the world that want their phones to be doing something else in their afterlife, so to speak. And if the rest of the device can be completely recycled, then we believe it's an entirely upcycled device. So again, this didn't come because of any sort of high-tech solution. It just came from using what's already there. And I'm thoroughly convinced that if it's not phones, that there's always going to be enough there that you can build similar solutions that can be very effective in new contexts. Thank you very much.
All the leaves are brown. Passed along the way. Well, I got down on my knees and I pretend to pray. You know the preacher like the cold. He knows I'm gonna stay. California dreaming.
vagina harbors hundreds of different kinds of microorganisms. Some tend to be especially prevalent, like lactobacilli. These bacteria produce an acid that lowers the vagina's pH, limiting what can survive there and preventing against certain infections. Candida yeasts are also usually present in small quantities. Most of the time, these fungi are harmless. The body's immune system keeps them in check, while other microorganisms like lactobacilli combat and outcompete them for nutrients and territory. But under certain conditions, Candida yeasts can cause infections. One species in particular, called Candida albicans, is the usual culprit of vaginal thrush, or yeast infections, which affect 3 out of every 4 people with a vagina. So how exactly does a yeast infection happen? Candida albicans yeasts are shapeshifters. And when the balance within the vagina is disrupted, like the pH increases, or there are fewer microbes to compete with, Candida albicans may assume their disease-causing forms. They multiply and metamorphose, substituting their rounded structures for elongated thread-like forms called hyphae. Then they secrete enzymes that degrade the epithelial cells lining the vagina and permeate the tissue. Immune cells rush to the site, generating some of the most recognizable symptoms of yeast infections: itching, burning, swelling, and redness. These may also be accompanied by a change in vaginal discharge, the fluid that's frequently flushed from the vagina to keep it healthy and clean. During a yeast infection, discharge may become thicker and whiter because the vagina is shedding more epithelial and candida cells. A few major factors like antibiotic treatments and lower immunity can make people more susceptible to vaginal yeast infections. When someone's immune system is compromised from illness or otherwise, their body may be unable to control Candida effectively. And in treating bacterial infections, antibiotics kill harmful bacteria, but they can also wipe out beneficial ones, like lactobacilli, allowing Candida to multiply more easily. Many other factors also help set the stage for yeast infections. Hormonal changes and diet alter the vaginal microbiome. Semen is relatively basic, so it can disrupt the vagina's pH. Tight, non-breathable, and wet garments incubate moisture and are thought to facilitate a more Candida-friendly environment. Soaps can damage the protective mucus that coats the vagina, making it easier for Candida to permeate. That's why many doctors recommend just gently washing the vulva with water. And it's important to wipe from front to back to avoid introducing more Candida as well as other potentially harmful microbes to the vagina. Most yeast infections are mild and clear up within 2 weeks. Antifungal medications usually offer dependable treatments by reducing the number of Candida cells, allowing the immune system and other microorganisms to regain control. And interestingly, the solution to treating some yeast infections could be more yeasts. Preliminary studies with probiotics containing the harmless yeasts we use in brewing and baking have shown promise in keeping Candida in check while reducing inflammation. But some yeast infections require more extensive therapies. About 5 to 10% of people with vaginas experience at least 4 yeast infections a year. For some of those, the cause seems to be genetic. Some people have gene variants that make it harder for their immune systems to recognize and regulate Candida cells. But why many others have recurrent infections is currently unclear and requires a lot more research. In fact, so does basically everything we've just talked about. We don't know nearly enough about the vaginal microbiome. This is probably because of stigma and underfunding when it comes to topics that traditionally fall under the umbrella of women's health. For instance, while erectile dysfunction affects a much smaller percentage of people than vaginal yeast infections, there's about 6 times more research on the subject. Hopefully, we'll soon have a better understanding of the many microorganismal multitudes we contain and how best to keep them in balance.
Sometimes you're forced to make a choice. See the bet, raise the bet, or fold. Some may say it's the same in love, like banging your head against a wall.
For nearly a decade, my collaborators and I at the Self-Assembly Lab have been working on material systems that transform themselves, assemble themselves, and adapt to their environment. From our early work on 4D printing, where we printed objects, dipped them underwater, and they transform, to our active auxetics that respond to temperature and sunlight, to our more recent work on active textiles that respond to body temperature and change porosity, to our rapid liquid printing work, where we print inflatable structures that morph based on air pressure and go from one shape to another, or our self-assembly work, where we dipped objects underwater, they respond to wave energy and assemble themselves into precise objects like furniture. Or at larger scales, using wind energy, we have meter-diameter weather balloons that assemble in the airspace above a construction site. For dangerous environments or harsh, extreme places where it's hard to get people or equipment, they can assemble in the airspace, and as the helium dies, they then come back to the ground, and you're left with a big space frame structure. All of this research is about taking simple materials, activating them with forces in their environment, gravity, wind, waves, temperature, sunlight, and getting them to perform, getting them to transform, assemble, etc. How do we build smart things without complex electromechanical devices? But more recently, we were approached by a group in the Maldives, and they were interested in taking some of this research and ways of thinking and applying it to some of the challenges that they've faced in terms of climate change. And the first thing that you do when you're approached by someone in the Maldives is say you want to go on a site visit. It is amazing. So we went there, and I actually walked away with a really different perspective on the future of climate change. Because you would imagine, the Maldives are sinking, they're screwed, what are they going to do? But I walked away thinking they actually might be the model, the future model of the built environment where they can adapt and be resilient rather than our fixed man-made infrastructure. But there's typically three main approaches to sea level rise and climate change. One of them is that we can do nothing and we can run away, and that's a pretty bad idea. As more than 40% of the world's population is living in coastal areas, as sea levels rise and as storms get worse and worse, we're going to be more and more underwater. So it's imperative that we solve this pretty demanding problem. The second is that we can build barriers, we can build walls. The problem here is that we take a static solution trying to fight against a super dynamic, high energy problem, and nature is almost always going to win. So that's likely not going to work either. The third approach is using dredging. So dredging is where you suck up a bunch of sand from the deep ocean and you pump it back onto the beaches. If you go to any beach around the northeast or western coast, you'll see that they use dredging year after year after year just to survive. It's really not a good solution. In the Maldives, they do the same thing, and they can build an island in a month, a brand new island they build from dredging. But it's really, really bad for the marine ecosystem, and then they become addicted to dredging. They need to do that year after year. But in the time that it took them to build that one island, 3 sandbars built themselves. And these are massive amounts of sand, so big you can park your boat on it, and this is what's called a site visit. It's really hard work. In Boston winters. This is massive amounts of sand that naturally accumulates just based on the forces of the waves and the ocean topography. So we started to study that. Why do sandbars form? If we could tap into that, we could understand it and we could utilize it. It's based on the amount of energy in the ocean and the topography in the landscape that promotes sand accumulation. So what we're proposing is to work with the forces of nature to build rather than destroy. And in my lab at MIT, we set up a wave tank, a big tank that's pumping waves, and we placed geometries underwater. We tried all sorts of different geometries. The waves interact with the geometry and then create turbulence and start to accumulate the sand. So the sand starts to form these sandbars on their own. Here's an aerial view. On the left-hand side, you'll see the beach that's growing. In the middle, you'll see the sandbar that formed. So these are geometries that collaborate with the force of the wave to build. We then started to fabricate one. This was in February in Boston. We have large rolls of canvas. It's a biodegradable material. It's super cheap, easy to work with. We then sew it into these large bladders, and then we flew over there. And I know what you're thinking. This is not the Fire Festival. This is real life. It's real. And we flew there with these canvas bladders in our suitcases. We got sunburned because it was Boston winter. And then we filled them with sand and we placed them underwater. These are exactly the same geometries that you saw in the tank. They're just human scale. Large objects filled with sand, we place them underwater. They're just really simple geometries. In the front of them, you'll see it's clear water. The waves are crashing over, it's quite clear. And then on the back side, there's turbulence. The water and the sand is mixing up. It's causing sediment transport, and then the sand is accumulating. You'll see some friendly stingrays here that visited us. On the left is day 1, the right is day 3. You'll see the sand ripples in the light areas where the sand is accumulating just after 2 days. So this was last February, and it's very much ongoing work. This is just in the beginning of this research. Over the next year and longer, we're going to be studying this through satellite imagery and bathymetry data to understand what the short-term and long-term impacts are of natural sand accumulation in the environment. And the bigger vision, though, is that we want to build submersible geometries, almost like submarines that we can sink and float, like adaptable artificial reefs. You could deploy them if there's a storm coming from one direction or another, or if the seasons are changing, you can use these adaptable reef structures to use the force of waves to accumulate sand. And we think this could be used in many coastal regions and many island nations around the world. But when we think about building smarter environments, think of smarter buildings or smarter cars or smarter clothing. That typically means adding more power, more batteries, more devices, more cost, more complexity, and ultimately more failure. So we're always trying to think about how do we build smarter things with less? How do we build smarter things that are simple? And so what we're proposing at the lab and with this project specifically is to use simple materials like sand that collaborates with forces in the environment like waves to accumulate and adapt. And we'd like to work with you, collaborate with us to develop this, to scale it and apply this way of thinking. We think it's a different model for climate change, one that's about adaptation and resilience rather than resistance and fear. So help us turn natural destruction into natural construction. Thank you.
Let's go. Yeah. For those of you that want to know what we're all about, it's like this, y'all. This is 10% luck, 20% skill, 15% concentrated power of will, 5% pleasure, 50% pain, and 100% reason to remember the name. He doesn't need his name up in lights, he just wants to be heard, whether it's the beat of the mic. He feels so unlike everybody else, alone, in spite of the fact that some people still think that they know him, but fuck him, he knows the code. It's not about the salary, it's all about reality and making some noise, making a story, making sure his click stays up. That means when he puts it down, Tox picking it up. Let's go.
Who the hell is he anyway? He never really talks much, never concerned with status, but still even him starstruck. Humble through opportunities given despite the fact that many misjudge him cause he makes a living from writing raps. Put it together himself, now the picture connects. Never asking for someone's help or to get some respect. He's only focused on what he wrote, his will is beyond reach. And now it all unfolds, the skill of an artist. This is 20% skill, 80% fear, be 100% clear, cause Ryu was ill. Who would've thought he'd be the one that set the West in flames? And I heard him wreck it with the crystal method, name of the game. Came back, dropped Megadeth, took him to church. I like Bleach, man. Ryu had the stupidest verses, dude is the truth. Now everybody giving them guest spots and stocks through the roof. I heard he fucking with that stock.
This is 10% luck, 20% skill, 15% concentrated power of will, 5% pleasure, 50% pain, and 100% reason to remember the name.
They call him Ryu, he's sick and he's spitting fire and Mike got him out the dryer, he's hot. Found him in Fort Minor with top, but a fucking nihilist porcupine. He's a prick, he's a cop, the type women wanna be within. Rappers hope he gets shot. 8 years in the making, patiently waiting to blow. Now the record with your notice taking over the globe. He's got a partner in crime, his shit is equally dope. You won't believe the kind of shit that comes out of this kid's throat. He's not your everyday on the block. He knows how to work with what he's got, making his way to the top. He often gets a comment on his name. People keep asking him, was it given that birth or does it stand for an acronym? No, he's living proof. Let him rock in the booth. He'll get you buzzing quicker than a shot of vodka with juice. Him and his crew are known around as one of the best, dedicated to what they do and give 100%.
Forget Mike, nobody really knows how or why he works so hard. It seems like he's never got time because he writes every note and he writes every line.
design, and I've seen him at work when that light goes on in his mind. It's like a design is written in his head every time before he even touches a key or speaks in a rhyme. And those motherfuckers he runs with, the kids that he signed, ridiculous, without even trying. How do they do it? This is 10% luck, 20% skill, 15% concentrated power of will, 5% pleasure, 50% pain, and 100% reason to remember the name. This is 10% luck, 20% skill, 15% concentrated power of will, 5% pleasure, 50% pain, and 100% reason to remember.
Let me tell you a story. It goes back 200 million years. It's the story of the neocortex, which means new rind. So in these early mammals, because only mammals have a neocortex, rodent-like creatures, it was the size of a postage stamp and just as thin, and was a thin covering around their walnut-sized brain. But it was capable of a new type of thinking. Rather than the fixed behaviors that non-mammalian animals have, it could invent new behaviors. So a mouse is escaping a predator, its path is blocked, it'll try to invent a new solution. That may work, it may not, but if it does, it'll remember that and have a new behavior. And that could actually spread virally through the rest of the community. Another mouse watching this could say, hey, that was pretty clever going around that rock. And it could adopt a new behavior as well. Non-mammalian animals couldn't do any of those things. They had fixed behaviors. Now, they could learn a new behavior, but not in the course of one lifetime. In the course of maybe 1,000 lifetimes, it could evolve a new fixed behavior. That was perfectly okay 200 million years ago. The environment changed very slowly. It could take 10,000 years for there to be a significant environmental change. And during that period of time, it would evolve a new behavior. That went along fine, but then something happened. 65 million years ago, there was a sudden violent change to the environment. We call it the Cretaceous extinction event. That's when the dinosaurs went extinct. That's when 75% of the animal and plant species went extinct. And that's when mammals overtook their ecological niche. And to anthropomorphize, biological evolution said, this neocortex is pretty good stuff, and it began to grow it. And mammals got bigger, their brains got bigger at an even faster pace, and the neocortex got bigger even faster than that, and developed these distinctive ridges and folds, basically to increase its surface area. If you took the human neocortex and stretched it out, it's about the size of a table napkin, and it's still a thin structure. It's about the thickness of a table napkin. But it has so many convolutions and ridges, it's now 80% of our brain. And that's where we do our thinking. And it's the great sublimator. We still have that old brain that provides our basic drives and motivations, but I may have a drive for conquest, and that'll be sublimated by the neocortex into writing a poem or inventing an app or giving a TED talk. And it's really the neocortex is where the action is. 50 years ago, I wrote a paper describing how I thought the brain worked, and I described it as a series of modules. Each module could do things with a pattern. It could learn a pattern, it could remember a pattern, it could implement a pattern. And these modules were organized in hierarchies, and we created that hierarchy with our own thinking. And there was actually very little to go on 50 years ago. Led me to meet President Johnson. Been thinking about this for 50 years, and a year and a half ago I came out with the book How to Create a Mind, which has the same thesis. But now there's a plethora of evidence. The amount of data we're getting about the brain from neuroscience is doubling every year. Spatial resolution of brain scanning of all types is doubling every year. We can now see inside a living brain and see individual interneuronal connections connecting in real time, firing in real time. We can see your brain create your thoughts. We can see your thoughts create your brain, which is really key to how it works. So let me describe briefly how it works. I've actually counted these modules. We have about 300 million of them, and we create them in these hierarchies. So I'll give you a simple example. I've got a bunch of modules that can recognize the crossbar to a capital A, and that's all they care about. Beautiful song could play, pretty girl could walk by, they don't care, but they see a crossbar to a capital A, they get very excited, and they say crossbar, and they put out a high probability on their output axon. That goes to the next level, and these layers are organized in conceptual levels. Each is more abstract than the next one. So the next one might say capital A. That goes up to a higher level. It might say Apple. Information flows down also. If the Apple recognizer has seen APPL, it'll think to itself, I think an E is probably likely, and it'll send a signal down to all the E recognizers saying, be on the outlook for an E. I think one might be coming. The E recognizers will lower their threshold, and they see some sloppy thing, could be an E, ordinarily wouldn't think so, but we're expecting an E, it's good enough, and yeah, I've seen an E, and then Apple says, yeah, I've seen Apple. Go up another 5 levels, you're now at a pretty high level of this hierarchy. We'll stretch down into the different senses, and you may have a module that sees a certain fabric, hears a certain voice quality, smells a certain perfume, and we'll say, my wife has entered the room. Go up another 10 levels, and now you're at a very high level. You're probably in the frontal cortex, and you'll have modules that say, that was ironic, that's funny, she's pretty. You might think that those are more sophisticated, but actually what's more complicated is the hierarchy beneath them. There was a 16-year-old girl, she had brain surgery, and she was conscious because the surgeons wanted to talk to her. You can do that because there's no pain receptors in the brain. And whenever they stimulated particular, very small points on her neocortex, shown here in red, she would laugh. So at first they thought they're triggering some kind of laugh reflex. But no, they quickly realized they had found the points in her neocortex that detect humor, and she just found everything hilarious whenever they stimulated these points. You guys are so funny just standing around was a typical comment. And they weren't funny, not while doing surgery. So how are we doing today? Well, computers are actually beginning to master human language with techniques that are similar to the neocortex. I actually described the algorithm, which is similar to something called a hierarchical hidden Markov model, something I've worked on since the 90s. Jeopardy is a very broad natural language game, and Watson got a higher score than the best 2 players combined. It got this query correct: a long, tiresome speech delivered by a frothy pie topping, and it quickly responded, what is a meringue harangue? And Jennings and the other guy didn't get that. It's a pretty sophisticated example of computers actually understanding human language, and it actually got its knowledge by reading Wikipedia and several other encyclopedias. 5 to 10 years from now, search engines will actually be based on not just looking for combinations of words and links, but actually understanding, reading for understanding the billions of pages on the web and in books. So you'll be walking along and Google will pop up and say, Mary, you expressed concern to me a month ago that your glutathione supplement wasn't getting past the blood-brain barrier. Well, new research just came out 13 seconds ago that shows a whole new approach to that, a new way to take glutathione. Let me summarize it for you. 20 years from now, we'll have nanobots, because another exponential trend is the shrinking of technology. They'll go into our brain, through the capillaries, and basically connect our neocortex to a synthetic neocortex in the cloud, providing extension of our neocortex. Now, today, you have a computer in your phone, but if you need 10,000 computers for a few seconds to do a complex search, you can access that for a second or two in the cloud. In the 2030s, you need some extra neocortex. You'll be able to connect to that in the cloud directly from your brain. So I'm walking along, and I say, oh, there's Chris Anderson. Oh, he's coming my way. I better think of something clever to say. I've got 3 seconds. My 300 million modules in my neocortex isn't going to cut it. I need 1 billion more. I'll be able to access that in the cloud. And our thinking then will be a hybrid of biological and non-biological thinking. But the non-biological portion is subject to my law of accelerating returns. It will grow exponentially. And remember what happened the last time we expanded our neocortex? That was 2 million years ago when we became humanoids and developed these large foreheads. Other primates have a slanted brow. They don't have the frontal cortex. But the frontal cortex is not really qualitatively different. It's a quantitative expansion of neocortex. But that additional quantity of thinking was the enabling factor for us to take a qualitative leap and invent language and art and science and technology and TED conferences. No other species has done that. And so over the next few decades, we're going to do it again. we're going to again expand our neocortex, only this time it won't be limited by a fixed architecture of enclosure. It'll be expanded without limit. That additional quantity will again be the enabling factor for another qualitative leap in culture and technology. Thank you very much.
Think about it. There must be a higher love down in the heart or hidden in the stars above. Without it, life is a wasted time. Look inside your heart and I'll look inside mine. Things look so bad everywhere in this whole world. What is fair? We walk the line and try to see, falling behind what could be. Oh, oh, bring me a higher love. Bring me a higher love. Oh, bring me a higher love. Where's that higher love? I keep thinking of. Bring me higher love. Bring me higher love. Oh, bring me higher love. Bring me higher Worlds are turning, and we're just hanging on, facing our fear and standing out there alone. A yearning, yeah, and it's real to me. There must be someone who's feeling for me. Things look so bad everywhere in this whole world. What is fair? We walk the line and try to see, falling behind and what could be. Oh, bring me a higher love, my Lord. Bring me a higher love. Oh, oh, bring me a higher love, my Lord. It's that higher love I keep thinking of. Bring me higher love. Bring me higher love. Bring me higher love. Bring me a higher love. Oh, bring me love. We need a higher love. Bring me, yeah, a higher love. I keep thinking of. Bring me higher love. Bring me higher love. Bring me higher love. A higher love. I keep thinking of. Bring me a higher love. Bring me a higher love. Oh.
A mountain separating two lakes. A room papered floor to ceiling with bridal satins. The lid of an immense snuff box. These seemingly unrelated images take us on a tour of a sperm whale's head in Herman Melville's Moby Dick. On the surface, the book is the story of Captain Ahab's hunt for revenge against Moby Dick, the white whale who bit off his leg. But though the book features pirates, typhoons, high-speed chases, and giant squid, you shouldn't expect a conventional seafaring adventure. Instead, it's a multi-layered exploration of not only the intimate details of life aboard a whaling ship, but also subjects from across human and natural history, by turns playful and tragic, humorous and urgent. The narrator, guiding us through these explorations, is a common sailor called Ishmael. Ishmael starts out telling his own story as he prepares to escape the damp and drizzly November in his soul by going to sea. But after he befriends the Pacific islander Queequeg and joins Ahab's crew aboard the Pequod, Ishmael becomes more of an omniscient guide for the reader than a traditional character. While Ahab obsesses over revenge and first mate Starbuck tries to reason with him, Ishmael takes us on his own quest for meaning throughout the whole universe, not excluding its suburbs. In his telling, life's biggest questions loom large, even in the smallest details. Like his narrator, Melville was a restless and curious spirit who gained an unorthodox education, working as a sailor on a series of grueling voyages around the world in his youth. He published Moby Dick in 1851, when the United States whaling industry was at its height. Nantucket, where the Pequod set sail, was the epicenter of this lucrative and bloody global industry, which decimated the world's whale populations. Unusually for his time, Melville doesn't shy away from the ugly side of this industry, even taking the whale's perspective at one point, when he speculates on how terrifying the huge shadows of the ships must be to the creature swimming below. The author's first-hand familiarity with whaling is evident over and over again in Ishmael's vivid descriptions. In one chapter, the skin of a whale's penis becomes protective clothing for a crewman. Chapters with titles as unpromising as Cistern and Buckets become some of the novel's most rewarding, as Ishmael compares bailing out a sperm whale's head to midwifery, which leads to reflections on Plato. Tangling whale lines provoke witty reflections on the ever-present perils entangling all mortals. He draws on diverse branches of knowledge, like zoology, astronomy, law, economics, mythology, and teachings from a range of religious and cultural traditions. The book experiments with writing style as much as subject matter. In one monologue, Ahab challenges Moby Dick in Shakespearean style. "Towards thee I roll, thou all-destroying but unconquering whale. To the last I grapple with thee. From hell's heart I stab at thee. For hate's sake I spit my last breath at thee." One chapter is written as a play script, where members of the Pequod's multi-ethnic crew chime in individually and in chorus. African and Spanish sailors trade insults, while a Tahitian seaman longs for home. Chinese and Portuguese crew members call for a dance, and one young boy prophesies disaster. In another chapter, Ishmael sings the process of decanting whale oil in epic style as the ship pitches and rolls in the midnight sea and the casks rumble like landslides. A book so wide-ranging has something for everyone. Readers have found religious and political allegory, existential inquiry, social satire, economic analysis, and representations of American imperialism, industrial relations, and racial conflict. As Ishmael chases meaning and Ahab chases the white whale, the book explores the opposing forces of optimism and uncertainty, curiosity and fear that characterize human existence, no matter what it is we're chasing. Through Moby Dick's many pages, Melville invites his readers to leap into the unknown, to join him on the hunt for the ungraspable phantom of life.
Yo! Jordan?
Come a little closer, Mal.
Okay. Hey. Well, must be kind of nice to be a genie, huh, Jordan? Wish I had your kind of magic.
Tight for a century of lonely nights, waiting for someone to release me. You're thinking of reading, blowing kisses my way, but that don't mean I'm gonna hear what you say, baby, baby. Oh, my mind is saying but my heart is saying no. If you wanna be with me, baby, there's a price to pay. I'm a genie in a bottle. You gotta ask me the right way. If you wanna be with me, I can make your wish come true. You gotta make a big impression. I gotta like what you do. I'm a genie in a bottle, baby. Gotta catch me the battle. I'm a genie in a bottle, baby. Come in. Music's fading and the lights down low. Just one more dance and then we're good to go. Waiting for someone who gets me. Mind is racing at the speed of light. Let's go and have a little fun tonight, baby, baby, baby. My mind is saying let's go. But my heart is saying no. If you wanna be with me, baby, there's a price to pay. I'm a genie in a bottle. You gotta ask me the right way. If you wanna be with me, I can make your wish come true. Just come and set me free, baby, and I'll be with you. I'm a genie in a bottle, baby. Gotta catch me the battle. I'm a genie in a bottle, baby. Come in. I'm a genie in a bottle, baby. Gotta catch me the battle. I'm a genie in a bottle, baby. Come in. My mind is saying let's go. But my heart is saying no. If you wanna be with me, baby, there's a price to pay. I'm a genie in a bottle. You gotta ask me the right way. If you wanna be with me, I can make your wish come true. Just come and set me free, baby, and I'll be with you. I'm a genie in a bottle, baby. Gotta catch me the battle. I'm a genie in a bottle, baby. Come. Oh yeah. I'm a genie in a bottle, baby. Gotta catch me the battle. I'm a genie in a bottle, baby. Come in. I'm a genie in a bottle, baby.
Be careful what you wish for, I guess.
I'm a genie in a bottle, baby.
In 1965, 17-year-old high school student Randy Garner stayed awake for 264 hours. That's 11 days to see how he'd cope without sleep. On the second day, his eyes stopped focusing. Next, he lost the ability to identify objects by touch. By day 3, Garner was moody and uncoordinated. At the end of the experiment, he was struggling to concentrate, had trouble with short-term memory, became paranoid, and started hallucinating. Although Garner recovered without long-term psychological or physical damage, for others, losing shut-eye can result in hormonal imbalance, illness, and in extreme cases, death. We're only beginning to understand why we sleep to begin with, but we do know it's essential. Adults need 7 to 8 hours of sleep a night, and adolescents need about 10. We grow sleepy due to signals from our body telling our brain we are tired, and signals from the environment telling us it's dark outside. The rise in sleep-inducing chemicals like adenosine and melatonin send us into a light doze that grows deeper, making our breathing and heart rate slow down and our muscles relax. This non-REM sleep is when DNA is repaired and our bodies replenish themselves for the day ahead. In the United States, it's estimated that 30% of adults and 66% of adolescents are regularly sleep deprived. This isn't just a minor inconvenience. Staying awake can cause serious bodily harm. When we lose sleep, learning, memory, mood, and reaction time are affected. Sleeplessness may also cause inflammation, hallucinations, high blood pressure, and it's even been linked to diabetes and obesity. In 2014, a devoted soccer fan died after staying awake for 48 hours to watch the World Cup. While his untimely death was due to a stroke, studies show that chronically sleeping fewer than 6 hours a night increases stroke risk by 4.5 times compared to those getting a consistent 7 to 8 hours of shut-eye. For a handful of people on the planet who carry a rare inherited genetic mutation, sleeplessness is a daily reality. This condition, known as fatal familial insomnia, places the body in a nightmarish state of wakefulness, forbidding it from entering the sanctuary of sleep. Within months or years, this progressively worsening condition leads to dementia and death. How can sleep deprivation cause such immense suffering? Scientists think the answer lies with the accumulation of waste products in the brain. During our waking hours, our cells are busy using up our day's energy sources, which get broken down into various byproducts, including adenosine. As adenosine builds up, it increases the urge to sleep, also known as sleep pressure. In fact, caffeine works by blocking adenosine's receptor pathways. Other waste products also build up in the brain, and if they're not cleared away, they collectively overload the brain and are thought to lead to the many negative symptoms of sleep deprivation. So what's happening in our brain when we sleep to prevent this? Scientists found something called the glymphatic system, a cleanup mechanism that removes this buildup and is much more active when we're asleep. It works by using cerebrospinal fluid to flush away toxic byproducts that accumulate between cells. Lymphatic vessels, which serve as pathways for immune cells, have recently been discovered in the brain, and they may also play a role in clearing out the brain's daily waste products. While scientists continue exploring the restorative mechanisms behind sleep, we can be sure that slipping into slumber is a necessity if we want to maintain our health and our sanity.
No, sir.